Yes. Any doubts till problem number 8? See, you have to kindly answer me when I ask you a question.
No, sir.
Are you
No, sir,
clear?
no doubt.
Are you clear or not?
Yes, sir.
Clear, sir.
That is simple interest,
Yes.
compound interest, effective rate of interest. Now, we go for the next very important, what to say, the concept here, which we call it as a doubling period. Please understand, which we call it as a doubling period. Sir, what is this doubling period? Or what we are going to use rule 72 and rule 69. See, when we talk about doubling period, we talk about how much time it takes for an investment to double in its value. That is, you do investment mainly to get something called RR. What is RR? Rate of return. So in finance, rule of 72, it is called rule of 72, is an estimate the amount of time is taken for the investment to double in its value. That is to get your rate of return. Simple calculation is what? Dividing 72 by your annual interest rate. To see how much amount it is going to be doubled. The number of years to take to double your investment. And I tell you, the estimation of the doubling time for the investment, which is a fairly accurate measurement. When you want to lower your interest rate rather than the higher ones. Now, annual interest rate, where I'm just going to copy the image and I'm just 1 minute, I'll put it in the group. One, 2 minutes. Please keep your WhatsApp open now. Please keep your WhatsApp open. One minute, I'm just posting it so you can have a look of that. Did you get it? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
You just open it and keep. So it will be easy for you to understand. Just open it and keep. So 1%, 72. Actual number of years, 69. This is the table you have to use. 2%, 36. 3%, 24. So the doubling period. So when it becomes 100%, you can see 0.72. The actual number of years will be 1. Can you understand now what is the doubling period? Yes or no?
Yes, sir.
I'm
Yes,
just, if there is no cooperation from this side, I'm sorry, please, you have to talk to me when I ask you. Okay. So I'm just losing my motivation, I'm telling you. Slowly, I'm just getting out of my motivation. So you can see the sheet. Rule of 72, doubling period is equal to 75 by rate of interest. The above rule can also be used to find the rate of interest as given. Rate of interest is equal to 72 by the doubling period. Same way, rule 69, period is equal to 0.35 plus, but generally they are not using this rule of 69. But anyway, for you to understand, I'm just doing it. But generally they use rule of 72. Okay, now we'll take up the first problem. Balakrishnan,
Yes, sir.
can you read the problem number 9?
Yes, sir. Calculate the rate of interest if the period of doubling of an investment is A 4 years, 2 6 years, using Rule 72.
Use rule 72. Okay. So now I'm just doing it.
RTA is 4 years.
Okay. So the computation of we can say it as the rate of interest. Computation of rate of interest. Okay. So here we can apply the doubling period rule. Doubling period is equal to 72 divided by rate of interest. Oh, I'll share. பாலகிருஷ்ணன் அடுத்தாதான் கேட்பான்னு எனக்கு தெரியும். தெரியுதா இப்ப பாலகிருஷ்ணா?
Yes, sir. Excel is shared.
So rate of interest is equal to 72 divided by doubling period. This is the formula you have to apply. So now we'll take up the first case. If the doubling period is 4 years. If doubling period is 4 years. So if the doubling period is 4 years, then we'll apply that rate of interest, whichever formula you can require according to the information, you can use it. So the rate of interest is equal to 72, okay, into 72 divided, what is the doubling period? Divided by doubling period into divided by 4
18.
into 100. How much do you get? Because it's a rate. How much do you get? How much do you get this?
1,800. Sir, should we do that into 100, sir?
Yes, because when how many times I've told, when you do the rate of interest, when you do the rate of interest, are you not supposed to convert into 100?
Yes, sir. Yes. Okay.
Just getting it. Okay, so you get 18%. Then
Sir, but if you do into 100 means it's coming 1,800. That's why I asked.
illappa 72
Sir,
by
72
4
divided by
into
4 is
100
8.
pa. 72 by 4 into 100 எவ்வளப்பா? Balakrishnan, how much you get?
Sir, 72 by 4 is 18, sir. 18 into 100 is 1,800.
அது எப்படி கால்குலேட் பண்ணுப்பா? அது 72 into 100 by 4 கூட போடுப்பா நீ. புரியுதா?
Okay, sir. Okay.
One minute. 72 divided. One minute. 72 divided by 4 into 100. 18% தான்ப்பா வருது.
Okay, sir.
Next, if doubling period is 6 years. Then the rate of interest is equal to 72 divided by 6 into 100. How much do you get?
12, sir.
12%.
Yes. Yes, that's all. Okay, now we'll go to the next problem. So are you clear with this problem?
Yes, sir.
Yes, sir.
Yes.
Yes,
So
sir.
now
Yes,
the
sir.
6. Huh?
Yes,
Hello?
sir. I told yes, sir.
Yeah. Now we go to problem number 10, where we are going to apply rule number 69. Again, I'm telling you rule number 70, just like rule number 69, sorry, just like rule number 72, 69 is also there. But however, rule of 72 comes in handy in case of non-continuously or simple compounding interest. So now most of the people, they don't use rule of 69, they use rule of 72. Okay, they use rule of 72. Similar, but the results could be very different because the table says that at 5% the rule of 72 number of years is 14.40, but rule of 69 14.15, and moreover the formula that you use is 0.35, that is the standard one, plus 69. You can ask me what is that 0.35? 0.35 is the we can say it's something a rate of return, the precise rate of return a person wants to get in his fixed deposits in the case of 5% or 10% or 15%. So this is rule 69. So the next problem is rule of 69. Rule of 69. Okay, the formula will be, so you can say computation of doubling period, computation of doubling period under rule 69. Okay, so here we can say that it's only they say 6%, 9% and 12%. So the doubling period formula will be doubling period is equal to 0.35. It's a standard one. That's the rate of return. Standard rate of return that is fixed. Then 69 divided by rate of interest. Okay. So we have three things. If the doubling period is 6%, then if the doubling period is 9%, if the doubling period is 12%. Okay, so the formula will be same formula will apply. So we'll take it like this: 0.35 plus 69 rule will apply divided by 6. Here 0.35 plus 69 divided by 9. 0.35 plus 69 divided by 12. Yeah, tell me what is your answer? How many years? You must say how many years?
Sir, 11.85.
11.85 years. Yeah. Yeah.
8.01 years.
How much? 8?
8.01.
Yeah, 8.01 or 02. 8.01 years. Next one.
Sir, 6.1.
6.1.
6.10 years. So again, I'm telling you the idea of learning doubling period using rule 72, sometimes 69 is to know how your investment is going to double within a given period to have a proper rate of return. Are you clear now?
Yes, sir.
Yes,
Yeah.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Now, we are going to go to the next set of problems. That is called future value, compound value or the future value. I have already told you what is the future value. Anyone can remember and tell me what is the future value? Anyone can tell me what is the future value of money?
Current plus interest.
Value of money at present plus interest. Value of money plus interest. Yes or no? Through that only we have
Yes.
calculated the simple interest and the compound interest. Now listen here. Normally, what happens is investment may be made at a different time period, such as at the end of the first year or the second year, third year or the fourth year, and so on. So the compound value received after specified period, say 4 years. In this case, first payment will be locked up for 3 years. Second payment will be locked up for 2 years, which we say n-1, n-2. And third payment remains locked up for 1 year, n-3, and so on. So this is what we call it as the future value of series of payments or services of payments. So you can see here we are going to see single cash flow and we are going to see about the annuity. Now if you take future value of the single cash flow, the formula will be 1 plus Rn, amount relates to its time is 0. Future value of the annuity is amount into 1 minus Rn minus 1 divided by R. Amount relates to year, number of years. Where N is equal to number of years for which money is invested. R is equal to rate of return on the investment. Note, the future value table, future value of annuity table can also be used without by calculation. So I am going to teach you using the table and without using the table. So I am going to teach you using the table and without using the table. Rogan?
Yes, sir. Yes, sir.
Rogan, when I called you, you're not there.
Sir, actually, my lab is going on. That's why I had to show the output there. This is why I had chosen the later slot. But
so you show the output there and show the waste put here.
No, sir. Actually, ma'am is very strict about the presentation. So we had
okay. So you can enjoy. You can enjoy in accounts class. Okay, you read the next problem.
So just a second, sir.
Can you read or you're tired?
No, sir. No, sir. I'm not tired. I just opened this class, sir. Just a minute. So someone else can do it. I can come with the next problem.
Nishita Tiwari. She'll say my lap is not working.
Yes, sir.
Can you read the
So the
7th
11th problem, right?
Yes. Thank you, Ma. Thank you so much.
Yes.
Yeah.
The Rohan makes an initial deposit of rupees 50,000 with free flow funds bank limited. The interest is compound at 10% annum for 6 years. Compute the amount on maturity.
Okay. Now, listen here. Rogan, 50,000 with free flow funds limit. That's just a name of the company. Compounded at 10% per annum for 6 years. Compute the amount on maturity. Just listen. See, in your cat or fat, you will not get all small problem. I may give you a case study. With the case study, I'll be asking small questions like this. So you must understand the case study and do it. Anyway, people who have already taken my paper, they know. Paper will be totally application paper only. You have to follow me what I'm saying in the class. One minute, I'm just writing the heading. So we go for question number 11. Okay. So here what we do is, so you write for Hogan value of cash, okay, future value of cash, or we can put it as single cash flow, single cash flow, single cash flow, okay, is equal to, just listen, amount, apply the formula, just see the sheet, apply the formula, that is, formula is 1 plus R power of n, okay, power of n, which is equal to, so amount is 50,000, 1 plus your rate of interest is 10%, number of years is 6. Yeah. Can you tell me now? How much do you get this? No, you forget that 50,000. See what is 1 plus 10% by power of 6. Anyone can tell me, please?
1.06.
1.06 or 1.7716?
1.7716.
1.7716. Am I right?
Yes, sir.
Now, listen here. 1 plus R, 6. See, 50,000 you don't bother. 1 plus R, power of 6, always you must find the value. So you have found the value as 1.7716. So that value, or you can do by direct calculation, or you can obtain the value from the future table. Are you clear now? Now, first I'll teach you to do directly. Then I'll teach you how to use the table. So 50,000 into 1.7716. How much do you do? What I'm doing now is the direct method. How much do you get this? How much do you get this?
88,580.
Yeah. Now, I'll just stop sharing this for a while. I'll show you the This is the direct method. But sometimes I'll also teach you how to use the table. Just I'll stop sharing for a while. Then I'll show you the table and then I'll come back to this. Just 1 minute, is opening. Yeah. Ravi? Ravi
Yes,
Teja,
sir.
what is the
Yes, sir.
what is the formula we have used? 1 plus 10% power of how many years?
N.
How many years?
6 years.
6 years. Now I'm just seeing the table, you can see. 6th year, 10%, how much you're getting?
1.7716.
How much you have taken there?
1.7716.
That's all. This is how you have to see your table. Yes, sir. Are you clear or not?
Yes, sir.
Yes.
Yes, sir.
Yeah. Same way, I'll also show you the annuity table. 1 minute. Yeah. I'll just share the Excel again. Okay. This is 11th problem. Okay. Yeah. Now we'll go to the 12th one. So somebody can, okay, I'll read quickly. All, yeah, yes. Hello. Yeah. Balakrishnan enters into an agreement to deposit 25,000 per annum for 4 years to a financier who will allow 8% interest per annum and repay the amount at the end of the 4 years. What amount will Balakrishnan receive at maturity? So, for Balakrishnan, so we can put it as future value of annuity is equal to amount into 1 plus R power of n minus 1 is the formula I've given you, divided by R. So now we'll substitute this formula. Amount given is 50,000 into, okay, into 25,000 into, now 4 amount, number of years is 4, rate of interest is 8%. Okay, now we'll substitute this. 1 plus 8%, no? Yeah, 8% Okay, close it. So yeah, number of years is 4. Number of years is 4 minus 1. R is what? R is nothing but, divided by R. It is divided by 8%. Tell me how much you get this? How much do you get this? Yeah, tell me how much do you get this? Leave 50,000. That amount you tell me how much you get it. You cannot even do more than 3-4 problems in a class. You're not. Hello. Hello.
Yes, sir.
How much do you get?
Sir, without 50,000, it's 15.74.
73.
How much? How much do you get, Rakanna? How much? 15 point?
74.
7375.
Have you divided the R?
Yes,
R,
sir.
1 plus R, the power of n, whole divided by n, whole divided by minus 1 divided by R. Actually,
Sir.
this should be power of n.
Power of n minus 1 or power of n?
No. 1 plus 8% power of 4. Then that whole minus by 1 divided by 8%.
Okay, sir. Okay.
I would have do because my lap is not working with this power.
Four point five.
Huh?
4.5.
4.5. Now we go to the future value table. See here. Future. I'll also teach you how to find in the table. Future value of annuity table. The same thing. So 4 years. Yeah. I'll just stop sharing that and show this again. You see this table, see that underneath table, 4 years, 8%. How much do you get? 4 years, 8%, how much do you get? 4 years, 8%, how much do you get?
4.5061.
That's what somebody told me, right? Are you clear or not?
Yes, sir.
Yes, sir.
Yeah. So we can do it like this straight method, or you can refer to the annuity method. 50,000 into that already you have calculated, which is 4.5061. How much do you get this? How much do you get this?
2,305. 2,25,305.
Yeah. 1 lakh.
2
Sir,
lakh,
2
sir,
lakh,
2 lakh.
2 lakh. Sir, 225.
Sorry, you also didn't tell me. I also made a mistake. See the problem. The amount is only 25,000. Can you see? See the problem, man.
Yes,
It's only
sir.
25,000.
Yes, sir. Then 112,525.
Yeah, 1,12,000.
525.
Am I right? It's correct.
Yes, sir.
Yes, sir. Yes, 652.
Yeah. Please send me the attendance, ma.
Yes, sir,
Rishita,
will send.
you will never
Yes,
answer
sir.
ma, when I ask you something immediately.
No, sir, I was unmuting.
I don't know
Yes,
whether you
sir.
left the class or not. Yeah, can we do one more problem? I can finish. I'll take only 2-3 minutes. Can we complete it?
Yes, sir.
Okay, sir.
Yeah. Calculate the future value compound interest on an amount of rupees 1 lakh borrowed at a compound interest rate of 12% per annum for 6 months, 1 year, 2 years, and 1,095 days. So I just prepare a statement. This type of problem, you have to prepare a statement showing the computation of compound interest. Okay. So here you can open columns like particulars, and then we have for 6 months. For 6 months. Then for 1 year. Then for 2 years. And the last one for 1,095 days. Okay, so first one we'll take amount borrowed. So for all the cases,
1 lakh.
1 lakh. Instead of doing separately, I'm just making a statement so that it will be very clear and you'll know the difference for all the periods. ₹1 lakh and then rupees 1 lakh. Okay, the next one, interest rate. interest rate, which we shortly call it as R. Interest rate. So for all the cases, it is 0.12. Am I right? It is 12%, so 0.12. 0.12. 0.12. Next, time period. Time period. So I can say time period of 1, 2, and we said 195 days. So we can put it like this: 0.195 divided by 365. How much do you get this?
3, sir.
3. 3. You can take it, round it off as 3. I'll put it as 0.5 here. They 0. Or I'll put it as 6 months. Then only it will be right. Okay, 6 months. Right. Now, the next one that you should know is the future value. We have to calculate the future value. The future value is nothing but, I've already told you the formula. FV is equal to B1 plus R 1 plus R divided by how much? Divided power of T. Power of T. Okay. So you tell me what is the value now? Calculate. P is the principal amount. 1 plus interest rate is 0.12. Number of years is, we can take 0.5. Can we take 0.5, 6 months?
Yes, sir.
Or we can take off. How are you going to take this?
Both are same.
Okay, you take this 0.5. Yeah, tell me how much do you get this? In this case, 1 lakh, 1 lakh, 1 plus 0.12. .12, 1 year. Here, 1 lakh, 1 plus 0.12, 2. Here, 1 lakh, 1 plus 0.123. Yeah, tell me the value now.
1,05,830 is the first one.
1 minute, Kana. 1 minute. How much?
1,05,830.
5,830. Yeah, next one.
1,12,000.
Depends upon the form. 1,12,000. Yeah. 1. What is the next one?
1,25,440.
1,25,440 or 400?
I got
440, sir.
440. Okay. The next one.
1,40,492.
492, ma.
Yes, sir.
Okay.
Sir,
Yeah.
in this case, you took the amount is compounded annually, right, sir?
No, I'm just going to do the next one. 1 minute. Don't be in a hurry. The next one, I'm going to find out
No, sir.
compound interest. Okay. Hello? Somebody asked me. Hello? Hello? Somebody asked me, man.
Yes. Sir.
You know what is the formula for compound interest here? Future value minus your principal amount. So you take the first case. Future value is 830 minus 1 lakh, the first case. The second case, 1,12,000 minus 1 lakh. Next, 1,25,440 1 lakh. Okay. Next case. Next case, 1,40,492 minus 1 lakh. That's all. So if you do this, you get the compound interest. So 5,830, 12,000, 25,440 and 40,492. Are you clear with this?
Yes, sir.
Yes?
Yes.
Sir,
Yeah.
but you took the amount is compounded annually, right, sir?
But there a number of years for every stage, the number of period is given, man.
Sir, no, sir. I am asking about the number of times compounded.
Yeah, the number of compounding only they are given 6 months, 1 year, 2 years, like that it's been given. Are you clear? Hello?
Sir, the 1 year, 6 months, those are all the time, no, sir.
Yeah, the compounding is like how I said in the previous class, number of years compounded. Got it?
Yes, sir.
Raviteja, number of years compounded means like at the end of first year, suppose there are 5 years. At the end of the first year, 4th year. At the end of the second year, 3rd year. But here there is no reason for that. We are not doing, see, that is applicable only when you have a series of cash inflow.
Okay, sir.
But in this case, that will not apply. At the end of the first year, 4 years, number of times compounded. At the end of the second year, 3rd year, 3 years. At the end of 3 years, 2 years. At the end of 4th year, 1 year. Okay, Raviteja.
Okay, sir.
This is just a single. Only one cash flow is there.
Yeah, fine, sir.
Yes, that's all. So any doubts in this? Hello?
No, sir.
See, I'm very sorry to say you people are not except 3 or 4 people, you are not cooperating with me. I'm just getting demotivated. I'll just step out of the class. You can have some other faculty because I told you and you promised me that you will cooperate. And I'm doing a problem except 4 or 5 people, nobody is cooperating. I'm sorry. Please don't make me to step down the class. I'm not bothered about your discipline, man. I'm not bothered about your attendance, man. But I'm very much bothered about your class interaction. I'm shouting. Nobody is replying to me. I have to call Rogan, Rishita, Balakrishnan. Like that I must call. Then only people will answer. So please, you have to cooperate with me. Otherwise, not possible to complete. We'll see tomorrow. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.